Yeah, so our research is called Amazonian Water Links, interconnecting the atmosphere, the surface, and the subsurface. And so what we're doing is this sort of deep dive into the waters of the Amazon because water really is the nexus that connects us all. Plants need water, animals need water, humans need water. And when we think of water in South America, naturally, we think of the Amazon. The huge rivers, the large floodplains, the big lakes, all the animals. But we really lack some basic understanding of how the water moves inside the Amazon through the big river basins, interconnecting countries in the atmosphere, interconnecting states. In Brazil, for example, one river can be born in one state and then move to another one and then finally find its mouth in another one. And so what we're trying to do is track the water that is in the Amazon. So first we start with the atmosphere, right? And so we see this water being evaporated in the Atlantic Ocean, and this water is transported by what we call the trade winds. So these are very strong winds in the atmosphere, and they transport this water towards the Amazon, and that it falls as rain, and they keep going until they reach the Andes. The Andes are these huge mountains, and then the winds just can't go further, and so they're redirected. And once they're redirected, first of all, a lot of water falls in the Andes. And then these winds keep going, carrying moisture that the forest is continuously pumping into the air through this process called evapotranspiration, right? Where the plants are taking water with their roots and pumping it into the air through their leaves. And so all this water that's being collected by these trade winds as they flow through the Amazon is then redirected to southern Brazil, to southeastern Brazil, and especially to the La Plata River Basin, which for South America is very important in terms of energy generation. So the Itaipu hydropower plant is there. But that's just the atmospheric component. And then we look, okay, what happens after this moisture falls as rain? And then we see the reverse. Because if we look at the atmosphere, Brazil exports water to Peru and to Colombia and to Bolivia. But on the surface, all this water that falls on the Andes coming from Brazil is rerouted through the surface, forming those big rivers that then flow inside Brazil again, forming the big Amazonas River. So Brazil is at the same time an exporter of water in the atmosphere, but then we import that water from the Andean countries via surface fluxes, which are the rivers. So the rivers that are born in the Andes carry all these nutrients with them from the Andean mountains, and then as soon as they hit this very flat part of the Amazon, these very large floodplains, they flood and they deposit all these sediments that feed the forests, that feed the várzea forests that depend on these nutrients to survive. But that's just the first two components of the story. And then we look at what's happening under the surface, which is what we call the invisible Amazonia, the invisible Amazon. Because all this water that rains infiltrates in the soil, and we can think of the soil as a big bucket. And so this water is retained there for a long time, but slowly seeps into the rivers. And that is why we still have rivers even when we don't have rainfall. So during the dry season in the Amazon, let's say in the Pará state, where the dry season can be very intense, we still have flowing rivers, even though we don't have rainfall for several months. Why is that? Because this bucket of groundwater, of soil water, stored rainfall from previous wet seasons from months and years before, and then slowly releases that water into the rivers and keep them flowing even when there's no rain. And this is important because we are going through a time of quick change, both climatic, so we're seeing precipitation declining in parts of the Amazon. We're seeing temperatures getting hotter, but also when we think about land use change. So a lot of the big river basins in the Amazon are being deforested, and one that always jumps to the eye is the Tocantins River. The Tocantins River is one of the most heavily deforested basins that is part of the Amazonia. And what our results show, and this is a spoiler alert, what our results show is that actually we can pinpoint a decrease in the amount of water that the Tocantins transports to land use changes, to deforestation, to conversion of forests into pastures. Understanding where water comes from, where it goes to, and where it is stored is crucial for us to develop adaptation and mitigation strategies to deal with both climate change and human-induced land use change.